Hey! OpenShift 4 brings a lot of great new features around cluster operations. Things like container operating system, one-click cluster updates, and machine API make management of the Kubernetes cluster much less of a hassle. But all of those new technologies that lay at the core of the OpenShift 4 are quite new. At some point, something will go wrong and you need to know how to troubleshoot your cluster issues. In this video, I will give you a few tips on how you can figure out what exactly happened with your OpenShift 4 cluster. We will start with examining the OpenShift console. First thing you need to know is that OpenShift comes with a complete monitoring stack out of the box. Every possible metric of every cluster component is collected by a built-in highly available Prometheus installation. You can examine these metrics directly via the OpenShift console. There are dozens of pre-built dashboards. For example, here you can see many detailed metrics about how etcd cluster is doing. There are also metrics and dashboards for the complete cluster as well as for the individual nodes. The built-in dashboards are great, but there is also a Grafana installation available for you. Inside this Grafana, you have exactly the same dashboards, but you get a bit more flexibility around visualizing those metrics. As you might know, every part of the cluster is managed by cluster operators. You can find the list of those operators in the cluster settings section of the console. In this list, you can see if any of the operators has any problems. You can also jump to the individual operator, like I'm doing here with the network operator. Remember that each operator is just another container in your cluster, meaning that you can see the logs and metrics of the operator just like any other container. Talking about logs, you can always check them right here in the console. The logs you see in the console are taken directly from the cluster node where the container is running. Additionally, you can configure the cluster login. What it means is that you will get the Elasticsearch cluster and Kibana to store the logs for extended periods of time and visualize and analyze them in a more convenient way. There is also an option to forward all the logs to the external log storage of your choice. If you have a problem with individual cluster nodes, you can always check them in the compute section of the console. There are metrics and the current state of each node and machine. Some of the Kubernetes resources are not visible in a nice way in this console, but you can always find them if you go to the search section. In this search form, you get a list of all the resource types available in the cluster, and you can also see each resource in details. Also, you have a list of the custom resource definitions at the bottom of the menu. Many cluster configurations are stored as the custom resource definitions. Once again, you can see each of those resources in details right here in the console. Naturally, you can also do all of this with the kubectl or the OpenShift CLI. There are many things you can see in the OpenShift console or with the CLI, but sometimes your cluster is so broken that none of those options are available. In this case, it helps to have some way to log into the cluster nodes directly with SSH or a tool like AWS Session Manager. Once you're inside the node, you have most of the standard Linux utilities to investigate what's wrong with your cluster. You can check the network state with the SS utility, for example, or you can also verify IP tables. All the logs from each pod on this node are stored right there, so you can inspect them and search through them. One thing you need to remember is that OpenShift is using CoreOS, so you don't have a normal package management at your disposal. Instead, you can use rpm OSG command to verify the latest deployment and check if it matches your expectations. Other than that, it's still a regular Linux file tree, so you can see all the configuration files in the etc directory if you need to check the container registry configuration that is used by the cri-o, for example. Also, you can check different disk details and overall just navigate this node like a normal server. Just keep in mind that the actual file system is a bit special because of the way OS3 layers it. Talking about cri-o, this will probably be your main candidate for troubleshooting. There is a cri-ctl tool that works similar to Docker or Podman CLI. You can get the list of all containers running on this node and then, for example, find the etcd container. You can then exec into this container and run etcd-ctl commands to figure out if it works fine and if all the etcd nodes are okay. Just remember that almost everything in OpenShift is running inside the container. On the node level, cri-o is the tool that manages those containers, so cri-ctl should become a big friend of yours. Finally, if you lost a normal way to log into the cluster and query the Kubernetes API, you can log into the control plane node and use the kubeconfig from there to query the API. The kubeconfig is available at var-lib kubelet directory. kubectl is already installed on each node, so you can just export the kubeconfig variable and start investigating the broken cluster's API as usual, like you can get the list of the nodes or the pods, for instance. That's it for this video. I hope those tips will help you to fix your cluster if something really wrong will happen with it. Well, I also hope that nothing such bad will happen in the first place, but as you know, hope is not a strategy, especially in Kubernetes cluster operations. That's it for this video. Please tell in the comments section below what other OpenShift topics you would like to see covered. If you or your company are interested in OpenShift or Kubernetes consulting and training, you can contact us via the email address provided in the description. Don't forget to subscribe to our channel and press the like button. Thanks for watching!